Okay, so let's take a look at an application where we can actually sort of see these ideas of periodicity and so forth sort of in action. Now, do you know what a tidal wave is, by the way? A tidal wave is what happens after an earthquake. You have an earthquake, and of course everything sort of gets shaken up a little bit, including the water. And of course you have this huge mass, of water. So all of a sudden either drops or goes up, and it starts these huge waves, also known as tsunami waves. And it turns out that these waves are enormous. In fact, here's some sample. Look at those things. Those are very threatening looking. And they start and they fall, and boom, 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 boom. And now let's suppose that we have one of these tsunami things going on here. And suppose that the waves, each individual wave is traveling at a speed of, let's say, 540 feet per second, which is about 370 miles per hour. So really fast. These things are just ripping through. Suppose that the height of the peak of the wave is 50 feet. 50 feet. So you can see this is 50. You can see that that's a huge fish. That's like a whale if that's 50 feet, because that fish is, basically 50 feet high. Anyway, now the question is, if the period of the waves, let's say, is 20 minutes, so what that means is that it takes 20 minutes basically to go from sort of crest to crest. So from here, for this wave to get to here, it will take 20 minutes. The question is, what is the length between each wave? So what is this length right here? Well, I gave you a lot of information, right? We know, for example, that the waves are traveling at a rate of 540 feet per second. I tell you that the height is 50. And I tell you that it takes 20 minutes to get from here to here. So the question is, how long is this? Well, there's a lot of information there. We have to synthesize what's going on. These waves are very much like sound waves in that they're sinusoidal. So they have this sort of sine function type aspect to them. But all I care about here is finding the length of the period. So let's think about how to find the length of the period. First of all, is the amplitude, which is 50 here, at all relevant? The answer is no. The amplitude doesn't play a role in this at all. That's just sort of a dead rat, which is just there to throw us off the scent of the real mission. The real mission is to try to find this length. What do I know? I know that the waves are traveling at a rate of 540 feet per second. And I know that it takes each of these waves sort of 20 minutes to get through to the next period. So the period of the wave is 20 minutes. Now, I'm going to have to probably get all this in the same units. Here we're talking about feet per second. So to get this into seconds, I better take this and multiply it by 60. And that equals 1,200 seconds. So that's how long it takes to get from here to here. And I know how fast we're traveling. So the question is, what's that distance? Well, it's just distance equals rate times time. The rate, I know, is 540, and the time is 1,200 seconds. And so what's this? Well, you just multiply these two numbers together, and we get 648,000 feet. And what is that in miles? Well, if you have to divide this by 5,280, and you get 122.7 miles. So that's how far these are apart. These are really huge distance. So notice the key to doing this, though, was just to realize that I want a period length from this sort of sine-like function type thing. And to get the period length, notice the amplitude played no role in this. So that was just a complete red herring. And all I do is I have the speed, and I know how long it takes, and so I can actually figure out the period length. This is sort of like the 2 pi over absolute value of b to find the period length. But now it's sort of encoded in this rate type thing, so I need to use the fact that distance equals rate times time. Anyway, you can see in the real world, these sort of sinusoidal type things do occur, and figuring out these periods turns out to be a valuable thing, but not very hard. Anyway, I just wanted to show you a little thing about period. Up next, we'll take a look at some more exotic trig functions. Like, what does tangent look like anyway? I don't know. We'll see.